Okay, so when we talk about a chemical formula, so if we were talking about sodium nitrate, you guys know what the chemical formula of sodium nitrate looks like. You can sit there and write it on a piece of paper. We know it's NaNO3, right? So can you tell me how many sodiums do we have in sodium nitrate? Jeff, how many sodiums do we have in sodium nitrate?
In sodium nitrate?
How many sodiums?
Got one.
We got one. How many nitrates? I mean, how many nitrogen?
3.
Nitrogens? We have 3.
Oh, no, 1.
We have
3
1.
oxygen.
Yeah, that's right. 3 oxygens. Okay. So we know that subscript only pertains to the one that it's right next to, unless you have something in parentheses, right? So you're able to sit there and tell me how many of each of the atoms that are in there. Piece of cake, right? Not too hard?
No.
Good. Okay. How many atoms of each are in the formula unit of ammonium carbonate? Jennifer, ammonium carbonate, what does that look like?
NH4 plus.
NH4 plus, okay. And carbonate?
Carbonate is
CO3.
CO3? And what would be the charge associated with that?
2 negative.
minus.
2 negative. So then how many ammonia will I need to balance it out?
2.
2.
Okay. Okay, so our chemical formula is going to be NH4 parentheses 2 CO3. Okay, so how many nitrogens do I have here?
2.
How many hydrogens?
8.
How many carbons?
1.
And how many oxygens?
3.
Okay. So that lets me know how many of the atoms I have. Now, if we wanted to calculate the weight, we would use the atomic mass, right, of each one and added it all together. So for instance, we have 2 nitrogens. So how much does nitrogen weigh? What is the atomic mass for nitrogen?
14.007.
Okay, so we're just going to round to 14. Okay, so 2 times 14, 28, right?
Yeah.
Yeah.
What about oxygen? How much does oxygen weigh?
16.
I mean, sorry, not oxygen, I got carried away. Hydrogen. But we'll put that down here for later. Hydrogen, how much does hydrogen weigh?
1.
1 times 8.
8.
Carbon, how much does carbon weigh?
12.
12 times 1.
12.
And 3 times 16.
48.
So then we add them all together.
9.
So that's 96, and we use atomic mass units because we're going to be talking about a single unit, right? Okay, so then that will let me know how much a single unit of ammonium carbonate would weigh. Okay, and the reason why we call this a single unit, we call it a formula unit, because really when we're talking about ionic compounds, they kind of behave a little bit weird, right? And so, for instance, if we talk about sodium chloride, okay, sodium has a what charge associated with it? In sodium chloride,
Minus.
sodium has a minus charge,
Plus.
a plus, right? So we know that if we had just sodium alone, it would be in a plus. And then we know that Cl would have the minus. Okay, so when we talk about that sodium plus, really what happens is that sodium has a positive charge all the way around it, right? So that means that anything that's negative is going to be able to sit there and interact with it. So the chlorine is going to surround it. You're going to have one on the front, one on the back, one on the side, one on the side, one on the top, one on the bottom. They're going to surround it. And then vice versa for the chlorine. I'll show you what it looks like in a second. So that's what really happened. Now, the way that we measure the mass is called the formula mass. So this would be the formula mass of this compound, since it's an ionic compound, is that we look at what we call the formula unit. This here is the formula unit. It's just one of the balanced charges of these. So that represents our formula unit. So let me show you what I mean. So you guys don't think I'm totally crazy, maybe a little crazy. Okay, so this is what sodium chloride really looks like. Here's our sodium ion, here's our chloride ion. And you see how it's alternating, and that how the sodiums are being surrounded by the chlorides. You guys see that?
Mm-hmm.
Okay. Now the same thing is happening with the chlorides. It's being surrounded by the sodiums. Exactly the same thing. Okay. And so when we talk about it, we only talk about a formula unit. We only use a formula unit to measure the mass. So we only use NaCl to measure the mass. And that's it. So we don't take them all into consideration. We don't calculate them all up and then divide by how many we have. We don't do that. We just take a formula unit. Do you guys get that? Simple? Okay, so formula mass pertains to ionic compounds, where molar mass, or not molar mass, molecular mass pertains to a molecule or a covalently bonded molecule. Okay, so for instance, if we're talking about carbon dioxide, CO2. CO2 is how many carbons?
1,
1 carbon. How many oxygens?
2,
2 oxygens. So carbon weighs
12,
and oxygen weighs
16,
12 times 1. 2 times 16. You guys can answer. 32. Okay. So all together, carbon dioxide is going to weigh 44 atomic mass units. Okay. AMUs. Okay. So the difference between a molecule, molecular mass and formula mass. Formula mass is always going to be pertaining to an ionic compound. Molecular mass is going to be pertaining to a covalent compound. the way you calculate them are exactly the same. Are we clear?
Yes.
Okay. And again, ionic compound, covalently bonded compound. This is carbon dioxide. Okay. Pretty simple.
Yeah.
Yes.
Okay. So calculate the formula mass of aluminum nitrate.
Ammonium.
I'm sorry, ammonium nitrate. I was just going to give you a different problem altogether. Okay, now you guys don't all have to yell at me at once. There's 29 of you.
Wait, you want us to calculate ammonium nitrate?
Ammonium nitrate.
Okay.
Melissa,
Yes.
what is the chemical formula for ammonium nitrate?
The what? I'm sorry?
What is the chemical formula for ammonium nitrate?
Mm. That's a good question.
Abel, can I help her
Well,
out?
I can help with the beginning. The ammonium would be NH4 plus,
Okay,
and then nitrate NO3 negative.
okay. So how many of each will I need to balance each other out?
One of each, so they're good.
Okay, so then I'd write it as NH4 NO3. Okay. Abel, how many nitrates do I have here?
1,
Are you sure?
2, my bad.
I have 2 nitrates.
Yeah.
Okay. So how much does nitrogen weigh?
Nitrogen weighs 14, approximately
Okay. 14 times 2?
28.
How many hydrogens does it have?
8.
There's 8 up here?
No, there's 4.
Hydrogen weighs how much?
1.
4 times 1.
4.
And oxygens. How many oxygens do we have?
3. 3.
3. Oxygen weighs
16.
16 times 3.
48.
So if we add these together, $70 AMU. Simple?
Yes.
Good. So should we make it a little more challenging?
Okay.
Okay.
I have a question.
Yep.
I'm still like a little bit confused where you got like the weights of them. Like where you found like 14, 1, and 16.
The atomic mass.
It's on your periodic
Oh.
table.
Okay.
Your atomic mass.
Okay.
Wouldn't it be 80?
Okay. I'm glad somebody caught my mistake.
I literally had to take out my calculator. I was like, is it me or is it him?
I was just gonna see how long you guys are gonna let me get away with it, so. Okay, so in this context, pretty simple. All you're doing is adding up everything, right? Not too hard? Okay, good. So let me introduce you to some more terminology now. So you guys know the difference between molecular mass and formula mass? You understand what a formula unit is? Right?
Can you go over molecular mass again?
Sure. How about this? We can type it down, type it out. So molecular mass and formula mass are calculated the same way, but molecular mass pertains to covalently bonded compounds. Where formula mass pertains to ionically bonded compounds. Okay, so, but you calculate them exactly the same way. Okay, so it's just chemists, we get hung up on these little details. This is one of those little details that we get hung up on, right? Most cases, most people don't distinguish between them, okay? Unless you're going to be a chemist, okay? Although you will see it occasionally because chemists write the books and write the test. So you will see it in that regard, okay?
Thank you.
Okay. So I have a question for you. One dozen. Does a dozen only pertain to donuts?
No.
No.
Can I use a dozen for anything?
Yes.
Yes.
What does
Yeah.
a dozen mean?
12.
12 of anything, right? So I could have 12 husbands or 12 wives, 12 girlfriends, 12 boyfriends, 12 kids, right?
Yeah.
So in all those cases, I could say I have a dozen husbands, a dozen wives, a dozen girlfriends, a dozen boyfriends, and a dozen kids. Would that be right?
Yeah.
Yeah. Just sounds like a lot of work.
I second that. Yes. Having that many relationships, Lord. Yeah.
And a lot of money.
And a lot of money. Yes, that is true. That is definitely true. Okay, so we know that a dozen always means 12. Right? So in chemistry, we have something that's very similar. We have what we call the mole or a mole. So a mole, 1 mole equals 6.022 times 10 to the 23rd. Okay, just like a dozen, it's always going to equal that value, right? We know 1 dozen always equals 12. Well, 1 mole is always going to equal 6.022 times 10 to the 23rd. Now, this is called Avogadro's number. A lot of people say avocado's number because it looks very similar. Okay. So repeat after me. 1 mole equals 6.022 times 10 to the 23rd on 3. Are you guys ready? 1 mole, I guess you say 3. 1, 2, 3. 1
One
mole
mole
equals
equals
6.022
times
10 to the 23rd.
third.
Okay, say it one more time.
1 mole
Mole
equals
equals
6.022
6.022
times
times
10
10 to the 23rd.
Okay, now you guys got to remember that. Okay, okay. So if I have a mole of iron, how many atoms of iron will I have?
6.022 times 10 to the 23rd.
Excellent. Piece of cake, right? Not too hard.
No.
Okay, so now I have another question for you. So if I have, we'll go back with the dozen right now, and then we'll go to the mole. So if I have a mole of grapes, if I had a dozen of grapes and a dozen of apples, how many apples do I have?
12.
12.
How many grapes do I have?
Well,
12.
Okay. So would they weigh the same?
No.
Okay. Good. Okay, now that's all clear. It makes perfect sense, right?
Yes.
Yes.
If I have a mole of grapes and I have a mole of apples, are they going to weigh the same?
Yes. No.
Are they going to be the same quantity?
yes.
Yes. Yes.
Okay, so no, they're not going to weigh the same, but they're going to be the same quantity. Okay, so moles pertain to quantity. It doesn't pertain to mass. Now we can relate them by using what we call molar mass, right? And molar mass is just grams per mole. Okay, and we'll talk about that here in a second. So you're saying something weighs so many grams per mole. Okay, so are you guys ready? Moving on.
Wait, one last time. So mole pertains to a quantity, right?
That's correct.
Okay.
And so for us to get the relationship with mass, we're going to have to use molar mass. Right?
Okay.
Oh, let's just talk about molar mass since we're here. Molar mass. Molar mass is, the units for molar mass is grams per mole. Now, your periodic table, okay, I'm getting ahead of myself. So let's take one step back. So if I have one molecule, can I see it with my eyes?
No.
No.
Now, with a mole of molecules, for instance, if I have carbon weighs 12 on our periodic table, so it also weighs 12 grams per mole. Okay, so that means if I have a mole of carbon, it's going to weigh 12 grams. Are you with me?
Yes.
That's the conversion.
That's our conversion. Yes. Okay. So could I see 12 grams? Can you weigh 12 grams on a scale physically?
Yeah.
Yeah.
Right. So I can actually see 12 grams. So the whole purpose for us using the mole is to get quantities that we can visually see or visually weigh or visually move around or react with, because it's really hard for us to sit there and react with a single molecule of carbon and then a single molecule of oxygen gas, right? Or single atom of carbon and a single molecule of oxygen gas to make carbon dioxide. It's really hard for us to do that, right? Because I don't know, do you guys go and do labs on a single atom or a single molecule?
No.
Or are you guys using
No.
dumps and dumps of stuff?
Yeah.
Yeah. Okay. So So we know that we can't work with single components of everything. So we have to scale up to something that we can physically work with. And so that's what the mole allows us to do, right? Because we're using so many more, 6.022 times 10 to the 23rd, right? That's a whole lot, okay? So again, this is called molar mass, and we'll go back more over it as we go through, and it'll start clicking, I promise. So let's move forward. Maybe. Okay, so we've already talked about Avogadro's number, right? And Avogadro's number is actually based upon carbon 12. Okay, carbon's important, carbon's the whore, you know, it kind of sets the tempo for everything. So our scale for the periodic table is essentially based upon carbon 12. Okay, because that's how they determine 12 grams was going to be equal to 6.022 times 10 to the 23rd units. So carbon atoms. Okay. So knowing everything you know now, here's my first question. A sample consisting of 0.25 moles of ammonia. How many ammonia molecules is this? How would I calculate this? Where would I start?
With the given.
With the given. And our given is?
0.25.
0.25 more.
0.25 moles of ammonia. Okay, so if I have 0.25 moles of ammonia, what am I going to use to calculate the number of molecules of ammonia?
Mole. 6.022 times 10 to the 23rd.
0.22.
Okay, so on top or on the bottom?
Bottom?
You would have 1 mole on the bottom, right? And then 6.022 on top.
That's right. We'd have 1 mole on the bottom. And 6.022 times 10 to the 23rd molecules of ammonia. Okay, how many sig figs would this be?
2.
2, that's correct. Okay, piece of cake?
Yes.
Yes.
Good.
So would it be the same conversion would be the same thing to find atoms too?
Yep,
Okay.
or underwear, or pantyhose. Yep. Okay. So, oops. So we've already talked about molar mass, right? And so we get our molar mass from the periodic table as well. So it just allows us to do that scale up. So AMU, atomic mass units, and molar mass are very similar. Only thing, one is scaled up to a higher level. Okay? Okay, you guys get that?
Can you
Yes.
explain that again?
Okay, so for instance, AMU make reference to a single atom, right? Molar mass makes reference to a whole bunch of atoms, a mole of them to be precise, right? Which is 6.022 times 10 to the 23rd. The values that you have, we said, like for instance, carbon weighs 12 AMU. Well, carbon also weighs 12 grams per mole. And that's just a scale up. So for instance, if you were cooking for 25 people, right? And you have a recipe for 5 people, can you scale it up?
Yeah.
Right?
Yeah.
So essentially that's what we're doing. We're scaling it up so it'll be a bigger quantity that we're working with. And so molar mass allows us to do it in terms of something that we can physically handle compared to trying to work with a single atom, because you can't see a single atom without using a specialized microscope. So you couldn't put 2 atoms together to do a reaction, you know, unless you use the specialized microscope. Is that very feasible? You guys all have specialized microscopes at home that you can sit there and do chemical reactions with?
No.
No.
I don't have one either, right? So it's not practical for us to do it that way. So we do it in large quantities. And so that's why we have to scale up to the mole. We have to use, in terms of quantity, we have to use a mole to sit there and set that standard. And so they're directly equal to each other at that point. Okay, so the periodic table will give us the molar mass of all of our atoms, just like it gave us our atomic mass of all of our atoms. Okay? Does that make sense?
Yes.
Yes.
Okay, good. So let's test this out. Calculate the molar mass of calcium fluoride. So the first thing I want to do is do what?
Figure out calcium fluoride.
Okay, so what is the chemical formula for calcium fluoride? Ibrahim, chemical formula for calcium fluoride. Ibrahim, are you there? Okay, Angie.
CAF2.
Calcium fluoride? You said CAF2?
Yep.
Okay, perfect. Okay, so if we wanted to calculate the formula mass, the molar mass, what is it going to be? How many calciums do I have?
1.
Okay, so it's 1 times, what is the atomic mass of calcium?
40.
40, so it's also going to be 40 grams per mole. Okay, so how many fluorines do I have?
2.
2.
And what is the molar mass for
19.
fluorine? 19.
Yeah.
Okay, so 38 plus 40.
78.
And the units would be grams per mole.
Oh.
Okay, you don't want to just use grams. You always want to use grams per mole, because then it'll keep you keeping track of all your units. Okay? Piece of cake? Not too hard?
Yes.
Good job. Okay? Okay. Okay, so here in this figure in panel A, this very first panel with the balloon, right? These are all elements, right, that have 1 mole. And okay, in panel B, these are all ionic compounds that have 1 mole in it. Okay, or I should say compounds or molecules. Ionic compounds or molecular compounds. Okay, so now that you guys know that, right? Now I need you to help me out here. Okay. So if we have iron, and iron it weighs 55.85 grams per mole, right? In that cup, how many atoms of iron are there?
Wouldn't it just be one?
Does that look like one atom of iron? Can you see one
Oh,
atom of
no,
iron with
no,
your
no.
eyes?
No.
I am like, damn, if you can, boy, we need to talk. I have some things that I want you to do. So obviously it's not one. So then what is it?
55.85.
That's how many grams? 55.85. How many atoms of iron are there? Okay, remember at the very beginning of the class, I told you guys, I don't know if I told you guys, I've been saying it all day, that you're gonna forget. I told you to repeat it over and over again. Why did I tell you to repeat it over and over again?
We have to divide it by the mole.
Yeah, right, because it's the mass divided by the mole. So if that is 55.85 grams, how many atoms must be in there?
6.02.
We divide it by 6.22, whatever. Yeah.
Times 10 to, yes. So in that cup, there is 6.022 times 10 to the 23rd atoms of iron.
Yes.
So that also means in that other cup with aluminum, there is 6.022 times 10 to the 23rd atoms of aluminum. Okay, so do you guys see it now? Do you see, and you see how often we will make that mistake, right?
Yes.
Yeah.
Okay. So, and if you look at these don't weigh the same. They're all different weights, right? But they have the same quantity in all of this, just like those apples and grapes that we were talking about.
Yeah.
Okay, are you with me?
Yes.
Okay, good. Okay. So you are carrying out a laboratory reaction that requires 0.0360 moles of barium chloride. How many grams of compound do you measure out? What am I going to do here? Raul, where am I going to start?
Barium chloride.
Barium chloride. So what does barium chloride look like? What is the chemical formula for barium chloride?
BA.
Just CL.
Cl2.
Yeah.
Okay. So what am I going to do next?
I'm guessing you find the formula mass.
Okay, so let's find the formula mass. Or do you want the molar mass?
Molar mass.
Molar mass. Okay, so I have 1 Ba. I have 2 Cl. So Ba weighs
137.
and Cl weighs
35.
So here we may not want to round too soon because this guy's going to give me what? 70.9. And then this guy's going to give me 137. 3. So that's 208.2. And the units, grams per mole. Okay, so what am I going to do with this now? I have the molar mass. I have the chemical formula. What am I going to use it for?
With the avocado number?
It's asking me how many grams. Is
How many
grams
grams?
quantity? What was that?
We divide it by the 0.0360.
Do we divide it by that? Shouldn't we probably start off with that? Since that's our given?
We need to, I mean, it's given, so we can cancel the
The
mole.
moles. Okay, so we have 0.0360. So we want to use that as our starting point, right? Our given,
Yes.
okay? So it's the same concept. Start off with your given. And then, can I use this guy down here to get rid of my moles?
Yeah. Yes.
Okay, because we know that this, when I put it like this, it really means this. It's 208.2 grams per 1 mole. That's what per means, right? It's divided by 1 mole, right? Doesn't that mean that?
Yeah.
So then I could just put that in up here to get rid of my moles, can't I?
Mm-hmm. Yes.
Okay.
Number 1.
Okay, so then oops. Then my moles are going to cancel out. And then I'm going to be left with just grams. And that's exactly what I want. So what do you guys get?
I got 7.5.
How many sig figs should I have?
3. Or wait,
That's right, 3. 1, 2, 3.
7.495.
7.495. Anything after it? Or
Well,
is it
there's
exactly?
2.
What's that?
EA.
That was a 7.4952.
4952. So then we would round up, right?
Yes.
You need to divide those numbers or make a multiplication.
So when they're right next to each other on the same row, like here up top,
Mhm.
this is multiplication. That's multiplying.
Oh, okay.
If the number was below it,
Okay.
then it's division.
Mm-hmm. Okay.
Okay, piece of cake.
Yes.
Yes.
You think we can do another one?
I believe we can. Okay, let's see. Actually, we're gonna do another one that's a little more challenging, though. Okay, so but before we do that, let me give you some hints. So if you're given molecules, atoms, pantyhose, right? You're going to use Avogadro's numbers to get to the number of moles, right? Now, if you need to get to the number of mass or the mass number, or a mass, then you want to use molar mass. So if you have moles and you're going to mass, you need to use molar mass. Okay? So you're kind of using moles as your gateway from quantity to mass. You guys good with me so far?
Yeah.
Yeah.
So this is basically just saying the same thing. So if I have mass, then I'm going to use molar mass to get the number of moles. If I have moles and I want to get to quantity of particles, then I'm going to use Avogadro's number. Okay, so let's test this out by another problem. Determine the mass in grams of 3.2 times 10 to the 24th molecules of sulfur tetrafluoride. So what am I going to do? First thing,
Find the chemical formula.
okay, what is the chemical formula for sulfur tetrafluoride?
It's F or S.
S,
F or
F4.
is it? I'm sorry. No, S F4. Yes.
Okay. Okay, so now we have the chemical formula. So what are we going to do next?
Shoot.
Calculate.
Get the weight for the sulfur and the fluoride.
So molar mass.
Yes.
Okay, so let's calculate the molar mass. So we have 1s, we have 4f. So what was the mass of S again?
Where's
32.
Okay, 32 point, you said 06?
Yes,
Yes.
sir.
So I think we can round. So 32, okay, and F?
19.
19. So 108 grams per mole.
Yes.
Okay, so what am I going to do next?
We will get the given.
Okay, so 3.2 times 10 to the 24th molecules of SF4. What am I going to do with it?
Is the mole convert or right?
You said put the moles on the bottom?
Or molecules?
Okay, so say that again.
Well, we're trying to find grams, right? So
Yep.
would we use mole or molecules?
Okay, right now we have molecules.
Do we need to get rid of those, right?
So we need to get rid of molecules. How do we get rid of molecules?
Auto number?
Avogadro's number. So what is Avogadro's number?
Oh, okay. I was gonna,
6.022 times 10 to the 23rd.
Okay, 6.022 times 10 to the 23rd. And that's molecules of SF4 over 1 mole of SF4. Okay, so that gives me moles now, right? Just
Yes.
got rid of our molecules. Okay, we're left with just moles. Is that what I want?
Yes.
Mhm.
No,
No, we want it in grams.
We want grams. We want grams. So we got a little ways more to go, right?
Yes.
Okay, so what am I going to do next?
We get the 108
wait.
108
on the top, yes.
on the top. Okay, 108 on top,
SF,
grams of SF,
then 1 mole SF.
okay, over 1 mole of SF. Okay, so then the moles of SF cancel out, and then we're left with our answer.
Yes.
Just gotta multiply and divide. So in this case, we're multiplying everything in the top row. That's what I would always do. And then I divide the stuff in the bottom.
Okay.
Where'd you get 1.08 grams?
It was
Right here.
the total of the sulfur tetrafluoride.
It's the molar mass. Okay, how many sig figs do I want?
2? I know.
2 sig figs. So if I have 5, 7, 3.896 grams. So what will my final answer be?
$5.7.
5.7 times what?
$10.23.
Times 10 to the third power, you said?
I said 23, but is it 3?
No, it's not 3. So if you do the math, right? So you have 3.2 times 10 to the 24th divided by 6.022 times 10 to the 23rd. Right? So then the 23rd and the 24th, that's going to cancel out, just leaving 10. So it can't be that much left over. So my answer I got was 573.896 grams. And you told me that that's the same thing as 5.7 grams. Is that true? So I can pay you $5 instead of $500. That'll be okay?
No, wouldn't it be 10 to the 5th?
Would it be 10 to the 5th?
I don't know. That
4.7. If here's the decimal, count your decimal. So you count it over 1, 2. So it'll be 5.7 times 10 to the 2.
When I put in the calculator, I get 46 times 10 to the 46.
Okay, so let's work on that math part. We'll work on it together. So when you're entering it in the calculator, what you're probably doing is, I'll tell you how to enter it. Do it like this. So first do your 3.2, and you're doing times 10 to the 24th, right? So what are you using? Are you using EE, or are you using times 10 to the exponent 24?
Right, 10 to the exponent 24.
Okay, so if you're using 10 to the exponent 24, you need to make sure that you put that in parentheses. So you need to put that whole number in parentheses, right? And then you're going to multiply that by 108. That's everything on top. And then you're going to divide by parentheses 6.022 times 10 to the 23rd. Because what you're doing is that you're doing a division part, but you're only dividing by the number. You're not dividing by this whole number. You're multiplying it by that number. That's how you end up with 43. Did you try it that way?
Yeah, and there's no, like I got 5.7, and then there's no times 10 to anything.
It should be 5.7. So it should be, and you did multiply it by 108, right?
Yeah, but like it's just not putting the times 10. It shows me all the numbers, so it would be, but
Okay, so let me see. Share your screen, or not share your screen. Share your calculator. Put your calculator up so I can see you. Hold on, let me open my. Come on. So that means that you got to turn your camera on.
yeah, I'm trying.
Okay.
You see it?
Okay. Yep. Yep. I see it. So it's screwed up somehow because it should have given you it should be 5.7 times 10 to the second power. So try entering it one more time where you have, oh, you know what I did? No, you're right. So 32 times 10 to the 24th times 108, and then divide that by, again, you want to put these in parentheses, and divide that by 6.022 times 10 to the 23rd.
So I was supposed to put 1.08 in parentheses too?
Yeah, just to be sure.
Okay.
Did he give it to you?
No, I did the same thing.
Okay, that's weird.
You should try using the EE.
I don't have one on this. That's why.
Does it say, do you have an EXP?
No, I don't think so. Let me see. EXP?
Yep.
No.
You don't have EXP? Okay. So do me a favor, send me in the chat, tell me the type of calculator you have, and then I'll take a look at it.
Okay, thanks.
Maybe it's in the wrong mode or something.
It was working on the other ones. It's just with two different scientific notation ones. That's when it wasn't showing me.
Yeah, because if you look at this, right, mathematically 3.2, and this is 10 to the 24, and this is 10 to the 23rd. So that's 3.2 times 10, because these guys are going to cancel each other out, leaving only 10 left over, right? So then you have 3.2, that'll be 32. 32 times 108 divided by 6.02. So if you enter that, that's going to give you your 573. But we'll figure it out. So just put it in the chat window and then I'll take a look at it. Okay, how are we doing on time? Okay, so let's talk about percent composition. So percent composition is just by mass. It's just the mass of the part over the mass of the whole. So if we're talking about a chemical compound, and we're, in this case, we're calculating the mass percent of fluorine in calcium fluoride. So in this case, what does calcium fluoride look like again? We've been using it all day. Chemical formula?
CAF2.
CAF2. So when we calculated the molar mass, we know that Ca was, we had 1 Ca, and that's 40. And we had 2 S, so 2 times 19, which is 38. We added them together, and we got 78. Okay, so if we're looking at just the mass composition of fluorine in calcium fluoride, we would just take our fluorine, because that would be the part, and divide it by 78. It's going to be our whole. Multiply it by 100. And then that's going to give us our percent fluorine in calcium fluoride. Okay? Piece of cake?
So the one that you're trying to find is on the bottom?
No, the bottom is the total. It is the total compound. The
Okay.
top is the individual component. So when we say part, it just means either I'm looking for the calcium or I'm looking for the fluoride, one or the other. And then the total is the calcium fluoride. Okay, so I have a question for you. So if 48.7% of calcium fluoride is the fluoride, then how much is the calcium? What percentage?
51.
What is the percentage of calcium in there? What was that?
51.23.
So 51.
Let me see.
Piece of cake. And if we wanted to verify that, we could do it the same way. So we know that it's 40 divided by 78. Times 100. And that should give us the same number. Or we could just subtract it by 100. Okay. Simple?
Yes.
Okay. Okay, let's see. Okay, so let's calculate the percent composition by mass of aluminum sulfate. So where am I going to start?
Writing down the formula.
Okay. So what is the chemical formula?
Al.
Al2.
Al2.
SO4 3.
Okay. So then what am I going to do next?
Find their mass.
Okay. So we have how many aluminums?
2.
2.
And each one weighs how much?
27.
27.
Okay, so that's going to be 54. Okay, how many sulfurs do I have?
3.
3.
3.
Okay. And that weighs
32.
So it's 36 for 3 of them.
96.
Yes.
Okay, and oxygen?
12.
12.
times 16.
Times 16.
192.
Okay.
Okay.
Is it 340?
So do we multiply the aluminum to 100%?
So how will we do it?
Do we multiply by, I don't know, 100%?
No, we don't multiply this by 100%.
The aluminum or no?
Nope. So to calculate for aluminum, we have to do each one separately, right? We want
Yeah.
percent mass for each one.
That's,
So,
that's right.
so how much aluminum? What was the weight of the aluminum?
27.
And there's 2 of them altogether, the total weight.
Oh, 54.
54?
So we go 54,
54.
and we divide it by the total mass.
Oh.
300.
And then you multiply that by 100.
Okay.
Yeah, that's what I meant.
Okay?
Divided by that. Okay. That's one. So it's 15.60, oh, 16%.
Okay, and then for the sulfur, what will I do?
Same thing.
Same thing.
96.
96 divided by 342
Okay,
times 100.
okay.
Okay. $300.
And then oxygen?
192 divided by the 342.
Okay. That's it? Piece of cake?
Yes.
Yes.
Good, good. Okay, now let's see how you can apply it a little differently. Oops. Okay. Okay, aluminum chlorate is 38.35% chloride. What mass of aluminum chlorate is needed as a source of 50.0 milligrams of chloride?
You start with a given?
Okay, so which one?
38.35.
38.35. And that's percent chloride. So what does that mean?
That there's 38.35% chloride in aluminum chlorate.
So I could say that this is equal to the mass of aluminum, mass of chloride over mass of aluminum chlorate. Times 100, right?
Yes.
Yes.
Okay, so do I have a mass for aluminum chlorate?
No.
I don't. As a source of 50.0 milligrams of chloride. So I don't have aluminum chlorate, but do I have chloride?
Yes.
Okay, so I could put that into this equation and then solve for this. Can I not?
Do you need to change it? Never mind.
That's a good question. So do I need to change it to grams? Because that's what you were going to say, right?
Yeah.
Yeah. So
Yes.
if my units are going to cancel out, will I need to change it to grams? Or can I just leave it to milligrams? Because milligrams over milligrams are the same thing as grams over grams. Grams over grams will equal milligrams over milligrams. As long as the units are consistent, they're going to be the same units. So I could leave it as milligrams. So then that way I don't have to go back and change to milligrams. Okay, so if they're being divided by each other, the same units, then the units are going to cancel out. It won't make a difference in that case. So I can use milligrams. Okay, so then let's do that then. I'm going to go ahead and move this and put my 50. Okay, so then to solve for that, I can get mass of our ClO3 equals 50.0 mg times 100 divided by 38.35%. Okay. How many sig figs do I want?
4.
2.
That's 2.
3.
3. 3 sig figs. Okay, piece of cake.
Why is it not milligrams?
Oh, thank you. See, you guys are keeping me on my toes.
So why was it we switched 38.35% with massive aluminum chlorate?
Because that's what we're trying to calculate, right? We want the mass. And so if you do, you cross multiply when you have an equal. So basically what I did multiply this side by mass of aluminum chloride, and then I multiplied that to the other side of the equal sign. So what you do to one side of the equal sign, you got to do to the other equal sign. Or you could sit there and just, okay, this guy is going to go over here. Since it's on the bottom here, it's going to be up top or on this side. And then this guy, since it's on the top here, it's going to be on the bottom.
Okay.
So they invert when they go across the equal sign.
Okay. When you're trying to find the percent or
Yeah, or when we're trying to find the mass. But that with any equation, like let's say we had x, here, and we had a number here, let's say 10. And then we had 200 here, and we want to solve for x, right? It's the same thing as doing to solve for x, we multiply both sides by x, right? That's the first thing that we would do. So then this cancels out, and then you just get 10x equals 200, right? But then if I just want to solve for x, I don't want to leave it as 10x, then I divide both sides by 10.
Dr. Henry had to go.
Okay, I'll see you. Have a good weekend.
You too.
Good luck on the exam.
Yes.
You see that, Jeff?
yeah. So
So it's the same thing. I just did it all in a single step.
okay. So it's just, we flip those to make it easier to divide and everything.
Yeah.
And cancel out the other like the percent and stuff because we're trying to find milligrams.
Yeah, that's correct. Yeah.
Thank you.
Yep. Okay, let's see.